Hi everyone, good evening. Today we are going to find the condition for reciprocity and symmetry in ABCD parameters. So before finding, let's try to see the equations for ABCD parameters. Generally, the ABCD parameters we will be writing in matrix form, which is nothing but A, B, C, D. So the condition for symmetry is the diagonal. Okay, what are the diagonal values? So we need to prove this derivation. The condition for symmetry is A is equal to D, and the condition for reciprocity is, so actually reciprocity means half diagonal. Here the half diagonal you should not do. Delta value is equal to 1. It's called determinant value. Determinant is AD minus BC is equal to 1. So this is the condition for reciprocity in the case of an ABCD parameter. Now, how to do this ABCD parameter evaluation? Okay, so first write down. So we have V1, I1, okay, V2, I2. So how to write down is, we'll write down the input port as V1, I1, that is equal to the ABCD transmission line parameters. Here we will write down it as V2 as well as I2. Okay, but here the current, if you take a two port, generally in this two port analysis, the current will be entering the port, but here we will assume the current is leaving the port, therefore the current is minus I2, which will come into the load. So therefore the minus polarity will come in this derivation. And now we need to find out the equations for ABCD parameter is V1 is equal to AV2 minus BI2 is the first equation. Second equation is I1 is equal to CV2 minus DI2 is the second equation. In these equations, what we need to find out is, so we need to consider the ABCD two port network, and we will apply the voltage at input port. The voltage we are applying is V1. The current, the two port network will demand a current of I1, and we are having an output port, and already we have been taken the current is minus I2, therefore there's no need to reverse. The current has to flow means what we need to perform is, we have to perform V2 is equal to 0. So now in this derivation what we have to substitute is, substitute output port is short circuited, and the current polarity no need to write down. Why? Because it's already interchanged here. So substituting this equation, these two equations is, so, and what we need to find out is response to the excitation. So the ratio we have to find out is response is I2, the excitation is V1. So this is called response to the excitation. So how to find out this response to the excitation, we will see here. So here V1 directly we are writing, and V2 is how much now? 0. Therefore 0 minus B into I2 is already there. So second equation is, here I1 is equal to C into V2 value is how much? 0 minus D I2. What kind of ratio we require now? I2 by V1. So this is already here. So this is I2. Bring this V1 to the denominator, which is nothing but here. So this is nothing but minus B. Now we got the value of B value. So similarly, let's try to perform the same in this side also. So take an two port network. Now we applied the input at output port. Let's try to apply the input to get an input current. Apply the excitation at output port. The current travel already we have been taken. This is minus I2, and so here actually the current will flow like this. This is nothing but plus I2, but sorry, plus I1, we have to take in reverse to verify the condition. So this is minus I1 and current has to flow means what you have to perform is we have to perform, then automatically V1 value is equal to 0. Okay, so now substitute the values of V1 is equal to 0 and substitute I1 is equal to minus I1 in the equations of transmission line parameter. So now V1 is 0, that is equal to A V2 minus B into I2. The next equation is I1, we have to write down it as minus I1 is equal to C into V2 minus D into I2. What we require is, so this is excitation, this is nothing but response. We need to find the ratio of response is I1 divided by excitation is ratio. There's nothing but I1 by V2. Identify where we have I1 by V2. So here we have I1 by V2. So but the disturbing term is I2. So we have I1 V2. The disturbing term is I2. We have to express I2 in terms of either I1 or V2. How to do is we verify here. So here we have A V2 is equal to B into I2. So now how to write down I2? I2 I can write down it as A V2 divided by B is equal to how much? This is nothing but I2 value. You see here I2 is expressed in terms of I1 and V2. So successfully we transformed. So here I can write down minus I1 is equal to C into V2 minus D into I2. How to write down I2? I2 I can write down it as A into V2 by B. So now I can take V2 as an common term. If you take V2 as common, this is C minus AD divided by P minus I1 is equal to VT into, take the LCM is B, which is nothing but BC minus AD. Okay, we need to find out the ratio of response to the excitation. What is response to the excitation? I1 by V2. So we will find out I1 by V2 is equal to minus of BC minus AD by B. Okay. So let's try to compare to verify the condition of reciprocity this with these two equations. So when you compare, here you are going to have minus B is equal to AD minus BC by B. Okay, so when you do this comparison, automatically you are going to get, so this is 1 by B, small modification, automatically B will get cancelled and ultimate value you are going to get AD minus BC is equal to 1. So this is the resultant value we are going to get AD minus BC is equal to 1. Now this is the condition for reciprocity in the case of an ABCD parameters. So now we want to prove the condition for symmetry. Okay. So here directly we will not do, we will make use of Z parameter model. So Z parameter model we have V1 is equal to Z11 I1 plus Z12 I2 and V2 is equal to Z21 I1 plus Z22 I2. what is the condition for symmetry in z parameter? So this value and this value. So how I will get z11 is z11 I will be getting only when I make this term as 0, I2 term as 0. There is nothing but z11 is equal to v1 by I1. So now substitute the same as how we got here in these expressions of ABCD parameters. So when you resubstitute here, what is the value of v1 is AV2 minus B I2 divided by I1 value is CV2 minus DI2. Apply the condition I2 is equal to 0. When I2 is 0, these terms will not be there. There's nothing but A by C is the value of Z11. Okay. So similarly, how to find out Z22? I can find out Z22 by performing this term as 0. What I have to make 0? I1 is equal to 0. When I1 is 0 here, we are going to get V2 by I2. Okay, so how to find out this V2 by I2? Okay, so in this we have to apply I1 is equal to 0. So in this case, let us try to make I1 is equal to 0. So when I1 is 0, that is equal to CV2 minus DI2. So here we can directly get the relation. So CV2, so just this expression you substitute I1 equal to 0 here. There's nothing to substitute here. So I1 is equal to 0, that is CV2 minus DI2. CV2 is equal to D into I2. We require the ratio of V2, bring this I2 to the denominator. That is nothing but D by C, V2 by I2, D by C. So that is equal to D by C. So what is the condition for symmetry in Z parameter? The condition for symmetry is Z11 is equal to A by C and Z22 is equal to D by C. There is nothing but the condition for symmetry. We are cross checking for Z. We will be getting the condition for symmetry of ABCD parameter. Therefore, the condition for symmetry in ABCD parameters is A is equal to D is the condition for symmetry, and the condition for reciprocity is AD, the determinant value is equal to 1. So as already I told, so the condition for symmetry you will be getting as the diagonal A is equal to D, and the condition for reciprocity is, what is the condition for reciprocity got? So the diagonal, the determinant value is equal to 1. So this is the proof, the derivation for the condition for reciprocity and symmetry in the case of an transmission line parameter, which are nothing but ABCD parameter. Hope you're able to understand the content. So if you have doubt, very simple. So express the ratio of response to the excitation. So first what you have done is, what is the excited I2 response is I2 by excitation is V1. We find this ratio, which is nothing but admittance. Here we are exciting output port and we are finding the current here. So the response is I1, excitation is V2. We are going to find out. So we are comparing this value, then we are getting the condition for reciprocity is AD. So just remember all the time. So you will get the condition for symmetry by comparing diagonal elements. You will get the condition for reciprocity by comparing half diagonal. But here the half diagonal element B is not equal to C. That's why you have to perform the determinant value is 1. Hope I have been cleared your doubts. And if you have any doubt, if you're watching the video for the first time, please like the video. Please share with your friends. And if you have any doubts, let me know in comment section. And if you're watching the channel for the first time, subscribe the channel. This is a free channel for the benefit of students and to make you complete about the concepts of electrical engineering, and this is a free channel for the development of students. We'll meet in the next video. Thank you for watching and for your support. Yours obediently, Ram.